Good morning, students. Today we are going to discuss about software design. Okay, so when we say software design, so this is the third step in software development life cycle. So the first step is communication, second step is plan, and third step is design. And then after the design, we go for coding and finally implementation. So, last unit we discussed about how we are going to collect the requirements and plan for the development. And once the plan is over, the next step we go for creating a software design. So, the software design will give you an overall representation of the system. So, the term architecture design is also the same. So, you are going to design the overall system that we say it as software architecture, or also you can use the term software design or an architecture design. So don't get confused. All these terms means that we are going to represent the system, okay, in a graphical representation generally. So here, when we say architecture design, we will be concentrating on three things. One is the style and the design, and how we are going to transform the requirements which we have gathered in the second step to architecture in the third step. That is what architectural mapping means. So these are the three main aspects which has to be known in this unit. Okay, so why we need an architecture? So as I told you, architecture of a system will describe the components and how they fit together. Okay, so it is going to represent all the components and how they are integrated into an entire system. So, this architecture will enable a software engineer to analyze the effectiveness of the design, then helps the software engineer to consider the architectural alternatives when he makes design changes. And the third main use of this architecture design is this helps in reducing the risk associated with the construction of the software. Okay, clear? So architecture is going to give you an overall picture of the system. So what are all the different components you have and how they are going to be integrated in the system. And these are the three main uses of the architecture. Okay. So the main topic under architecture design is architectural styles. So these architectural styles helps to describe a system which has some set of components like a database or some computational modules, so which is going to perform some functions. Okay, so your architectural style will give you a clear picture about what are all the set of components and how they are getting connected. That is the second point, set of connectors which is going to enable the communication, coordination, and cooperation among the components. And the third one is it will also tell you the constraints that define how the components can be integrated to form the entire system. Okay, and the last usage of this architectural style is the semantic models, which will help the designer to understand the overall properties of a system. So this will help the software developer to understand the system. Okay, so that is the main purpose of choosing an architectural style. So there are different architectural styles, and according to the software project, you have to choose any one of the architectural style. But all these architectural style will help you to know all these four main aspects, that is the components and how it is getting communicated or connected, and what are all the constraints and how it is going to behave, the entire properties of the system. Okay, So these are all the five architectural styles you have for the software development project. So first style is data centered architecture. Second one is data flow architecture. You have call and return architecture, object oriented architecture, and layered architecture. So among these four architectures, you can choose any of the architectural styles which is going to be suitable for your software project. You have to analyze the software project, and based on that you have to choose an appropriate style. So let me tell you, or let me explain you what are all the aspects of all these architectural styles. So let me start with the data centered architecture. From the name itself, you can identify data centered. So here the data is going to be placed at the center. Say, for example, look at the diagram here. You have n number of clients, and you have a data store, that is a global data store which is shared by all the clients. So, look at the picture here. You have some n number of client softwares, and you have a repository or data store at the center. Look at the arrow mark here. So, all the clients are making use of the common data store. Okay, so when I say a global data, or you are using a common data store, there are many advantages and disadvantages as well. Okay, let us see what are all the advantage and disadvantage of using a common data store. Okay, so as I told you, so here the data store is going to reside at the center, which is going to be accessed by all the components, which means that all the components can update, add, delete, or modify any of the data which is available in the data store. So that is the meaning of this architecture, data centered architecture. Okay, so the main goal is to integrate the data. So the data is going to be global, and all the clients can make use of the common data. So that is the main advantage. So here the data store can be a passive repository or an active blackboard. Let me tell you what is a passive repository means. Say, for example, if the client one is making some changes to the data. Okay, then the other clients may not have any idea about the changes made. So such type of behavior, we say it as passive repository. Okay, so look at the sentence here. A passive repository means the client software access the data independent of any changes to the data or actions of other client software. Okay, so if one client is making any changes to the data, the other clients may not be knowing it. So that is the meaning of this one. Okay, passive repository. So obviously, if you are using a passive repository, so what is the drawback is, if any one client changes the data, then the other client may be without the knowledge of the changes made. It can lead to a data ambiguity. Okay, in such case, there is a variation to this approach. That method, we say it as active blackboard mechanism. So what we can do is, if any client makes a changes, then all the other clients which are connected to the data store will get the notification about the changes made. Okay, so that wrong data may not be fetched by the other clients. So to overcome the drawback of the passive repository, we can use the active blackboard mechanism. Okay, so that whenever any of the client changes the data, the other clients will get the notification. Understood? So this is the data centered architecture. You have to remember the data is going to be at the center, which means that it is a global repository. All the clients can access the data. So the depository can be either passive or an active blackboard. The drawback of using a passive repository is if anything is changed, if any of the client changes any of the data, the other clients may not have the idea about it. So to overcome this, we have another mechanism called active blackboard mechanism, so that if any of the client changes the data, that can be notified. Okay. The next approach is data flow architecture. So when we have to use this type of architecture is when there is an input which has to be transformed into an output through some series of computational components, then you can choose this architecture. So the main goal of this architecture is modifiability. So here in data flow architecture, you have two type of styles. One is pipe and filter style, and the second one is batch sequential style. So look at the diagram here. So here you have some set of components called filters. So filters is going to perform some simple task, say like a plus b, or a square plus b square minus c square, something, some logics like that. So each filter is going to perform some computational logic. So it is going to transform the input into an output. Okay. So in this line, you are going to have some n number of filters in your project. So whenever we say a project, it is going to have some n number of computational logics. So each simple logics will be referred as filters, and the data flow among the filters, we refer it as pipes. Understood? Each logic which we perform in the project, we refer it as filter, and the data flow among the filters, we refer it as pipes. Okay. So whenever we are going to transform an input to an output through some set of computational logics, in that case we can choose data flow architecture. Okay. So batch sequential is, again here also you are going to have filters and pipes. The logic here is, so here we are going to have only sequential uh, data flow, whereas here we have in pipes and filter approach, we have parallel process flows. Look at the diagram here. In batch sequential, we have only linear data flow. Okay, that is the only difference. Understood? So next one is call and return architecture. So you would have come across this type of architecture when you have written a simple C programs, say for example, program for swapping or sorting, whatever it is. So like you would have written a main function and you would have written some functions. Okay. And you will be calling those functions for computing the logic, like inside the void main in your C program, you would have read a and b values, and you would have called swap of a comma b. That is, you are passing the input a and b to the method swap, so which in turn will call the subfunction, and there you will write the logic for swapping the two variables, and then you print it. So such type of logics can be represented using call and return architecture. Can you understand? You will be having some main program and you will be having some sub programs. So you're you're decomposing the project into some sub modules, where your main module will invoke a number of sub modules. Okay. So such type of logics you can use call and return architecture. So this architectural style is easy to modify and scale. So look at the diagram here. You have a main module yum. So yum is decomposed into three submodules A, B, and C. Again, A is again subdivided into two more modules D and E. B is divided into K, and L is decomposed into two more submodules L and M. So and it goes on. Can you understand? You have a main module. You are decomposing the main module into more than one submodule. So this type of architectural styles, we say it as main program or subprogram architecture. Okay. The next one is remote procedure call architecture. So again, this is also similar like your main program, subprogram architecture only. The only thing is your subprograms will be distributed among multiple computers on a network. Okay, it is not like your main function and the sub function is going to reside on the same system. So if it is residing on the same system means it will come into the first category, that is the main program and subprogram architecture. If your modules or distributed across different systems on a network, then only we say it is remote. So the general term remote means it is available outside the network. Okay, so it is available outside the system. Your main program will be in one system, your subprogram will be available in some other system connected with the network. You are going to communicate or you are going to call the method which is available in the other system. That is what we say it as remote procedure call. We are going to call a procedure which is available on some other system remote. Okay, that is the meaning of RPC architecture. Can you understand? So next, the fourth architectural style is object oriented architecture. So you all know the meaning of object oriented. So object oriented means main concept of object oriented architecture is data encapsulation. So we are going to wrap the data and methods together into a component so that you can protect your data from the other modules. Okay, for protecting your data, you have concepts like information hiding, and whichever data you want to give to your other submodules, in that case you can go for inheritance. So these are all some of the concepts you have under object oriented architecture. Okay. Then how these components communicate with each other is they will be communicating through message passing. So whichever project which has some n number of classes encapsulated with the data and functions and communicated using message passing, in such case you can go for this type of architectures. And the last architectural style is layered architecture. So from the name itself, we can understand you are going to have some number of layers. Okay. And in each layer, you are going to accomplish some set of tasks. Okay. So look at the diagram here. You have a core layer, you have a utility layer, you have an application layer, and you have an interface layer. So at the outer layer here in user interface layer, we will define some components which is going to provide an interface between the computer and the user. And next, the inner layer, maybe it may consist of some of the core task. Okay, maybe like the main logics what you wanted to perform. And intermediate layers here, say for example here it is an application layer and utility layer. So this is going to provide you some utility services and application related functions. So whenever you have a software project which is going to have some n number of layers, in such case you can go for choosing this layered architecture. So this is regarding the five different architectural styles which you have to represent your software project. Okay. So any doubts if you have, you can ask me. So next class we can discuss about the architectural mapping.